working in here. All right, guys. Going to do kind of our last new set of notes for our trig unit today. Talk about some inverse trig stuff. Okay. So it says kind of up top, our objectives or learning targets. We want to be able to evaluate inverse trig functions. That's like a unit circle thing. And then use trig equations and inverse trig functions to solve problems. All right, so let's go ahead and get to it then with the introductory stuff. So it says inverse trig relations enable us to find blank when given the value of a trig function. So that would be, it allows us to find theta. So far, if you kind of think about what we've done, kind of so far is with the right triangle. If you were given say an angle measure and a side, then you could find another side using a trig function, right? So finding a side. So this is kind of the stuff we would use to find the angle measure. Okay. So as you can see in the table here, these things kind of they're inverses of each other, right? So the original function would be like, so sine of theta equals whatever, and its kind of equivalent inverse would be arc sine of A equals theta, right? So it makes the angle measure the output. Now, I would just make a note about this, that I gave you guys some kind of bad information earlier. I said that you could use sine, sine to the -1, it looks like. I said that was the same as cosecant. That is false. Okay, those aren't the same. So that was my bad. We'll talk about how you say it in a second. But it doesn't mean that notation doesn't mean the reciprocal of sine, which is cosecant. So sorry about that. And moving on. Okay, so what does it mean? How do we read it? So one way to say that is the inverse of sine. The easier way to say it is arc sine, ARCSINE, arc sine. Well, I guess arc sine of A. And then the -1 indicates that it is the inverse and not the reciprocal. So that's what I was telling you guys earlier, that it was the reciprocal, but that again was false. Okay. All right. So let's go ahead and get into your types of problems. So before we do, we'll do some old stuff to review, kind of using your unit circle. So if you have that handy, your unit circle, you may want to reference that. It's going to be kind of hard to see on the board there. All right, so just to review, if we wanted to use our unit circle here to evaluate sine of 120, kind of what we look at there is we find our 120-degree angle, and then we remember, sine is either x or y. Anybody remember which one it is? Y, very good. So the y value at that angle measure is sine of 120, right? So square root of 3 over 2. Your calculator will give you, if you just punch that into your calculator, sine 120, your calculator, assuming it's on degrees, would give you the decimal equivalent to that, okay? But we get our exact value from the unit circle. All right, so then cosine of 240, so cosine is x for 240 is here. We want the x value, so -1/2. None of this is new, just kind of reviewing. The one where we do have to do a little bit of work is tangent. So like number 3 there says tan of 315. So there's 315. Anybody remember how to find tangent? It's not y and it's not x, but it's kind of a combination of the two. Yeah. y over x. So it'd be kind of like the slope of the line on a graph, okay? So y over x. It ends up being a little bit easy on this one. So we're kind of using a combination there. Negative square root of 2 over 2 over positive square root of 2 over 2. Okay, and this is the one, like I said, that's a little bit easier because anything over itself is 1, so we could really just read that as negative 1 over positive 1, right? So negative 1 overall. All right, so on that note, yes, Andrew?
Number 1 again. I know for number 2.
Square root of 3 over 2. All right, so on that note, with tangent, being a little bit tougher, I'm going to add a little bit to my unit circle here, and if you have yours out, you may want to too. Let's go ahead and write out tangent for all of our values, say in the first quadrant. Okay, let's go ahead and I'm going to add that. Okay. So again, tangent of say 0 over 1 here would be 0. Tangent, sorry, TAN of that equals 0. And again, we're gonna just kind of skip ahead, but basically, we've done all this work before, but you can just take my word for it now. Tangent, if I do 1/2 over square root of 3 over 2, I end up with square root of 3 over 3. And again, we can look at the details of how we get that if you guys want to. Tangent of this guy is 1, and then tangent of our 60-degree angle is square root of 3 over 1, or just square root of 3. Sorry, I did the first one wrong. Let's make a correction there. It's not square root of 3 over 2. It should be square root of 3 over 3. Sorry about that. Let's just make that 2 a 3 there. All right, and then finally, you get kind of a weird one up top there. But what is it if I put 1 over 0, or if I'm looking at a vertical line? What kind of slope does that have? Anybody remember the word? Undefined. So tangent here is actually called undefined. And if you checked the answer key yesterday, there was an undefined answer. And if you were wondering how the heck did that happen, that's how that happened. Okay. All right. So anyways, that'll help us here in just a minute. Okay. All right. So before we start looking at our examples, let's fill in the blanks one more time. So it says inverses of trig functions are blank because there are many values of theta for a particular value of a. The word here is periodic. So basically, it just depends on what part of the graph we're looking at for what something is. So here's an example they give us. They say arc cosine of 1/2 is equal to pi over 3 and 5 pi over 3. So let's try to find what they're talking about there. Cosine, again, we think x or y there. So which one is cosine? X, good. So where is x positive 1/2 is kind of what they're looking at here. So it would be there, and let's see, there. Notice the angle measures where x equals 1/2, right? It's pi over 3 and 5 pi over 3. Okay. So you may want to just make a note here. This is true. This is true because cosine of pi over 3 is equal to cosine of 5 pi over 3 is equal to 1/2. Okay, so that's what we're saying. So again, instead, it's really the same thing we normally do with the unit circle, except now we're just looking for our output as the angle measure. Okay, and you could say pi over 3, 5 pi over 3, or you could use 60 and 300. Right? Those mean the same thing. Okay. All right. So let's go ahead and do some examples together, and these are kind of your main types of examples from this particular lesson. All right, so number 1 says find arc cosine of 1/2, right? So again, I think about cosine first. What's that? Or sorry, arc sine. So I think about sine first, and that's associated with y. So then I look for on my unit circle where is y equal to positive 1/2. All right, so that would be here and over across here, right? So my angle measures there are, I could say 30 degrees and 150 degrees, or I'll just stay consistent with the notes and answer in radians, pi over 6 and 5 pi over 6. Okay, or if you prefer, just use the degrees. That's fine too. So if you wrote 30 degrees and 150 degrees, that's not wrong. Pick one or the other though. Okay. All right, so then you can kind of use your calculator to check this. Okay, your calculator will just give you the first one. Okay, so if I type in arc sine, so that's second and then sine. So second sine of 1/2, or I'll just type it in as 0.5. That gives me 30. When I'm in degrees, that gives me 30. It won't give me the 150, so that would come from the unit circle. Okay, but you can kind of check your answer that way, if that makes sense. Okay, so moving on to number 2. Number 2 wants us to find arc cosine. So cosine, we're thinking x. So on my unit circle, I'm looking for where are x values positive, square root of 2 over 2. Where are x values positive, square root of 2 over 2. Okay, so that would be well, change to the pen on me there. So that would be here, and down below it here. Okay, so you could say 45 and 315, or you could say pi over 4 and 7 pi over 4. Any questions so far? So you don't always necessarily, look across the x-axis or the y-axis. It depends on what ratio we're looking at, okay? And then again, the toughest is going to be arc tangent, just because those aren't obviously written all the way around our unit circle, but we could do that, okay? So we did a little bit of pre-work here. So number 3, arc tangent. So for tan, I'm thinking, y over x. We've already done that work to simplify. So where is tangent square root of 3 over 3? So that would be, we said, at a 30-degree angle. Forgot to erase my other stuff from the last one. So at a 30-degree angle, and then where else would it be positive? So I'm going to have you think about that for a second. So we know the combination positive 1/2 over positive square root of 3 over 2 gives me positive square root of 3 over 3. So where else would tangent be positive? Because it's not obvious. It's not written out. Yeah. When they're both negative. So what quadrant would that be in this case? That'd be bottom left, so quad 3. That's right. So when they are both negative is what we would be looking for there. So that would be this combo right here, right? So in this case, we are looking at pi over 6 and 7 pi over 6. Now, one other thing that might help in addition to what we have is that, remember that saying that we talked about a little bit, all students take classes or all students take calculus? That can help you with your signs too. So just to real quick recap that before you try a couple. All students take calculus. So really, sine and cosine are easy. But for tangent, though, how I could use this is, okay, so all of them are positive here. So in quad 1, tangent's positive, right? And then tangent is positive in Q3. So that's how that can be helpful too, that little saying. Okay. All right. But anyways, I want you guys to take a minute here, and you all try 4, 5, and 6, and then we'll review the answers here in just a sec. So arc cosine of square root of 3 over 2, arc tangent of 1, and arc sine of 0. Mike's still good. Rocking and rolling. All right. So kind of, if you're not quite going that quick yet, that's okay. Hopefully you'll kind of get there. But so number 4, arc cosine of square root of 3 over 2. You could have had for that 30 and 330, or if you're going radians, pi over 6 and 11 pi over 6. Okay, so for cosine, again, I am looking at x, right? So where are my x values? That. And it would be at here and here. All right, arc tan of 1 is going to be, so for tangent, thinking about that work we did earlier, right? So here's where tangent is 1. And then also down here in quad 3, right? So 225 and 45, or we could say pi over 4 and 5 pi over 4. All right, and lastly, on number 6, there are technically, I guess, 3 of them here, because we have we could call where tangent is where sine is 0, that would be here. Sorry, I should have done the y coordinate. That's where sine is 0. So we could call that 0 radians, 2 pi radians, and then across from it we could call it pi radians. So technically this one has 3: 0, 180, and 360, or 0, 1 pi, and 2 pi. All right. So any questions on those? Anybody want to look back a little closer at those, or is that kind of making sense? Just using the unit circle, right? All right. So then we'll look at our last example or 2 here. and call it a day. All right, so it says the inverse trig functions are called, so just to review what we call them again, we say arc sine. On our calculator, that is, looks like sine to the -1. Then you have arc cosine. On your calculator, looks like cosine to the -1. And lastly, arctangent. All right, so I'm going to go ahead and go away from my unit circle because on these examples, we kind of just use what our calculator says, even if it happens to be a special right triangle, okay? So we're going to practice using our calculator to finish up here. And again, if we're not taking a test over this, but if we were, one generalization you would make here is that anytime I'm solving for an angle measure, I'm using these inverse things. I'm not using the regular trig buttons, but the inverse, okay? All right, so let's go ahead and think through this. So here's the way I think through these, okay? So they asked me to find this angle, given its opposite side, and given is 24 adjacent or hypotenuse. Hypotenuse. So given opposite and hypotenuse, so we think sine there. So we could set it up as sine of question mark equals 12 over 24. You don't have to reduce here, but we can, so I will. All right, so then from that, we know we're going to use the inverse function to make the input the output. So we'll say arc sine, or sine to the -1, of 1/2. Again, that flips the input and the output, right? We've talked a lot about inverses lately, okay? And that's where you can just use your calculator, okay? So to get arc sine, you hit second and then sine. I guess we already did this one. But 0.5. And if we look at our notes, we had 30 and then another one, but we just worry about the first one when we're doing these problems. So 30 degrees. And just remember what setting your calculator was on. If you got a weird number, your calculator's probably on radians, okay? All right, so we'll do one more together. So again, we could have used our unit circle for the last one, but calculator's just fine. So on our last one, we have blank of question mark equals. Anybody know what trig ratio I'm going to use here in this case with what they give me? Cosine, very good. So we're going to use cosine, and the reason we know that is because they're asking me to find this given its adjacent side and the hypotenuse. So cosine equals 4 over 5. So that helps me with what do I type into my calculator? That'd be arc cosine of 4/5 or 0.8. So then we just type it in. Okay, that one is not on the unit circle. Okay, nothing on our unit circle has a cosine or an x value of 4/5, right? So this is going to be probably some irrational number. So arc cosine of 0.8 is about 36.8 something. Is that what you guys are seeing? All right. Usually we go nearest degree on these, so we'll call it about 37 degrees. All right, any questions? All right, so you guys try that one, and then we'll go over it here in just a sec, okay? While you're doing that, I'm going to go ahead and pass out your practice worksheet for this section for anybody who is interested in doing a few more of these problems to hone in on your skills. And if you're an environmentalist, you should do this just so paper's not wasted, you know. Yes.
So the project over trigonometry is that now until we come back.
No, you're gonna have until Friday to do it, but it's just for extra credit. It's not gonna.
The project is only for extra credit.
Yes.
Where do I find it?
I'll talk about it at the end today.
Okay. Here.
I mean, if he didn't want it, person behind it.
All right. Given the this is how we do this last one. Given the opposite and the adjacent sides, that kind of tells me, tangent. So tangent of what we're looking for is 14 over 29. And so we know what we're going to type in then is arctan of that fraction. Anybody have an answer for me on that? Did anybody type that in? Somebody did. Yes, Hayden? About 25.7, 25.8. So we'll just round to the nearest whole number and call it about 26. So that's the number you're looking for, though. Very good. So we'll say about 26 degrees. All right, gang. So I'll go ahead and end the video there. And hopefully this helps.